My name is Richard Elberger. I'm a partner solutions architect in the IoT segment in the APN, the AWS Partner Network. My day job is working with silicon providers such as Microchip, TI, Xilinx, and Qualcomm. From time to time, I get to do fun stuff like talk to you folks today. So we're a little bit short on time today, 35 minutes, so I'm just going to jump right into it. First, what we're going to talk about, for those who've heard of FreeRTOS, but haven't really had an opportunity to play with it, we're just going to seed some basic information about the FreeRTOS kernel. Then we'll talk about some use cases where people apply FreeRTOS and are looking to evolve their products or their services to use the Internet of Things. Then what I will be talking about is some evolution that we've been going through, both from an IoT connectivity and from an Amazon FreeRTOS perspective, things that have been changing over the last year. So if you have been a user of FreeRTOS or Amazon FreeRTOS or the embedded SDK from the AWS IoT device SDKs, then you get some other interesting information about how we're evolving things. Then just recently, I would say over the last year to a year and a half, we've been working with RISC-V, and I'll talk a bit about the work that we're doing there on the open hardware front, so building IoT solutions on top of RISC-V. And then I'll talk about improved contribution model that we just recently released a few weeks ago. So let's go ahead and get started. Let's talk about the FreeRTOS kernel. FreeRTOS is virtually everywhere. I'm looking around the room, and I see some controllers in the back, and I see some controllers up on the ceiling. And I wouldn't doubt it that my guess would be, based on how popular FreeRTOS is, that many of those are actually using the FreeRTOS kernel. Actually, what's really interesting, for those who may not be familiar with FreeRTOS specifically in the technical detail, is that FreeRTOS is really built for smaller controllers. When we're talking about a kernel here, we're not talking about something as large as the Linux kernel. The Linux kernel is a monolithic kernel. This kernel is a microkernel. The total amount of source that contributes to this kernel is 3 source files. That's it. Very simple, very sweet, very easy to use, yet very pervasive. FreeRTOS was created by a person named Richard Berry over 15 years ago. Over time, FreeRTOS has really grown, not just from the community, but also the number of products and services it has contributed to. Not only have people been using the FreeRTOS kernel directly, but also there are other derivatives, like, for example, if you're working in safety-critical environments or government, aerospace, and that sort of thing, where you need to have safety-critical applications, we actually have safety-critical versions of FreeRTOS that are curated by our partners. But again, the simplicity has lent to the popularity. The number of ports that have been done for FreeRTOS is just absolutely staggering. And like I kind of mentioned about what's in the room today, about what could be running FreeRTOS, FreeRTOS kernel has been applied to so many different industries, to virtually any vertical that you can think of, whether it's consumer devices, industrial devices, or aerospace devices. The FreeRTOS kernel is present in all those areas. But what you may have noticed over the last 5 or 6 years is a trend, and many people thought it was like I would say, a flash in the pan in the beginning, calling this thing IoT, the Internet of Things, such a funny name, but the marketing for that was just going out of control. But over the last few years, it's really gained significant speed and importance in the industry. So all these devices that have been created with the FreeRTOS kernel, those customers are now looking to build connected devices. Now, they may not always be internet-connected devices. They may be connecting to a gateway, which then connects to the cloud, but they're connected. And why is that? Because people today are seeing the value of the data that these devices are generating. They're also seeing the value of enabling customers to connect to these devices remotely and manage them. And many other similar connectivity use cases exist. All right? So connectivity is becoming a huge thing. But with that comes an additional layer of complexity that you have to deal with now. So let's talk about some historical stuff. So it's really we're going to go lower level. So shift up a little bit now. Most of the time what we're talking about are these microcontroller devices that we're controlling. Back in the day, what would we call this? Like writing code for these little chips. We would call that embedded development on bare metal. All right? So back in the day, before FreeRTOS existed, people would write C code, generate firmware, and flash that to the chip, and it just functioned. The issue with that is the ability to maintain that code over time. If you've ever written a program and you start off maybe 500 lines of code, 1,000 lines of code, before you know it, you're at 6,000 lines of code, and it's all tangled all over the place because you're afraid of changing too much, right? You'd have to really refactor to begin encapsulating and reusing code. In the embedded world, you have to build this application code on top of BSPs, board support packages, that come from the silicon manufacturer that enable you to build applications on these microcontrollers. And these have their own SDK that you have to interoperate with. Every single BSP from every single silicon provider is different. So now what you're doing is that you're gluing your application code specifically to that microcontroller. So we saw an opportunity for abstracting that one level up to making code more reusable. And that's where FreeRTOS really came into being. Over time, of course, what happened was a lot of third-party libraries were built on top of these board support packages. Many times when you needed to build an application, the third parties, there just weren't all the third-party libraries available that you could just plug and play for your functionality for your application. So still many times you had to go down to the BSP layer, maybe to work with some new kind of peripheral where the library didn't exist. But the FreeRTOS kernel enabled customers to encapsulate their code into chunks of code called tasks. If I write my code properly, my task code properly, there's a good opportunity for me to lift that up and be able to put that into another application. So the FreeRTOS kernel not only drove some really cool timing things in the way that communication happened between these tasks and that sort of thing, but it really enabled people to encapsulate their code, reuse their code, and make it simpler to read and manage. So what I talked about before with the bare metal coding, that's really what we are left with on the left-hand side up here. We would have parts of our application. Maybe I had something for sensing, and I had another chunk of code for actuation, like turning on a motor. And then I had another chunk of code for an LCD display. And logically, they were all like big components within my application. But I didn't have, in the beginning, a great way to pass along information to these singly managed chunks of code. So what did I end up having? Spaghetti code, right? Some of the worst stuff that can happen, because now if you get a new developer on task, they go in and they try to make sense of all this code that's wired up all over the place. So it's really a difficult thing to produce for maintainability. Whereas on the right-hand side, what FreeRTOS brought to our customers was the ability to encapsulate code and make these chunks of code loosely coupled. I now had the opportunity to write a chunk of code that ran in its own right, that was running on top of the FreeRTOS kernel, so it was time-shared, scheduled, all that kind of stuff. But I was able to loosely couple that code with another task, which was for the LCD display. And not only that, I was able to set priority of those two tasks. Like the screen had a higher priority over the sensing task, okay? So I didn't get into refresh problems. And the kernel took care of that kind of timing. Now, when you're loosely coupling things, right, this is just like if you're building distributed systems. Well, a task is like something that's running in a distributed system. I need to have a way to send a message from one task to another task. The way that you do that in FreeRTOS, and this is what comes with the distribution, it's not part of the 3 kernel files, it's actually an addition to that, which is using queues. So now you can use queues to send messages between tasks. You have a queue producer, which is the source task, and the queue consumer, the target task, right? And you can loosely couple that stuff. So this was a real paradigm shift in the way folks wrote embedded applications. But when I'm building an IoT application, a lot of things come into play. A lot more things that I need to think about. 2 big things. Security. That's a huge one, right? I don't want my security cameras to be taken over. And the other thing is my communications module. So I might be using Ethernet, or I might be using Wi-Fi, or I might be using BLE. At the end of the day, though, as a developer, the only thing I really care about is the application code that I'm running. Why should I want to care about the details of the Wi-Fi controller? Right? I just want to get my application running. So I care about the functionality, but the things that you need to think about on top of that is first the communication stack. I need to have TCP, right? If I'm going to connect to the cloud, I need to run over TCP/IP. I also need to have MQTT client to be able to make that connection to the MQTT server so I can send messages. I'm assuming a little bit that you know a little bit about the whole premise of IoT and sending messages to the cloud so the cloud can consume data, or my gateway can consume data. But you can just imagine it that I need to have something that manages the transfer of that data between 2 points. In order to communicate, but what I want to do, I just don't want to communicate that in plain text. I want to communicate that securely. Both AWS IoT Greengrass and the AWS Cloud requires that you connect using TLS 1.2 mutual authentication, which means that you need to have a TLS stack to work with, which means that you need to have not only the hardware, but the software to do all those crypto operations. So sure, I can create that secure connection, so I have security in transit. But what about security in rest? Because in my device, I have, in order to create that TLS 1.2 connection, I need to have a private key, right? And that private key represents the identity of the device. And if someone steals that private key, that's a big problem. Because now, other people, bad actors can impersonate my device. So that's why your devices should also have a secure storage. Could be like a crypto element, right? Usually those crypto elements, like it's called a secure element, has the ability to also offload crypto operations. Helps with your TLS connection and offloads a lot of the compute from your microcontroller as well. That goes hand in hand with over-the-air updates. When we're doing over-the-air updates, which enables you to continuously add value to your device and also update your device that may have some little bugs in it, because we only have little bugs in our applications. We just don't throw images around and have that device pick it up and apply it to the microcontroller. That image that gets reapplied to the microcontroller that has my app on it needs to have a signature. And that signature is verified by the bootloader. Okay? So all those things work hand in hand. So then comes in Amazon FreeRTOS. You may have heard of this. Amazon FreeRTOS is just a distribution of FreeRTOS. It's still open like FreeRTOS. FreeRTOS uses MIT license. Amazon FreeRTOS uses MIT license. So what's the big deal about Amazon FreeRTOS? Well, I can say before we launched Amazon FreeRTOS, we kept on getting several questions over and over again from our customers, right? I have a microcontroller. Can I connect to the cloud with that microcontroller? Can I actually construct that secure connection to the cloud with these libraries that I have on hand? Well, what libraries do I need? And how do I get started with all this stuff? So that's why we worked with a lot of silicon vendors to get qualified microcontrollers for Amazon FreeRTOS, so our customers that weren't really experienced, maybe not very experienced with embedded development, or if they were experienced with embedded development and wanted to reduce the risk of implementing software on hardware to connect to the cloud, they knew that the solution, that Amazon FreeRTOS was qualified for certain microcontrollers. So you can get started quickly, simply, easily, and without error. We also created a bunch of platform abstraction layers, which made getting started simpler. Instead of going down to the BSP or the Wi-Fi controller documentation and running a dozen or 2 dozen API calls to connect to a Wi-Fi access point, you only need to set up a couple of structures and make one method call to connect to a Wi-Fi access point. That's it. So with all these individual libraries comes a lot of complexity, right? And what we wanted to do was ensure that the APIs that you need to actually know to get your application code to run was limited. Sure, all this is open source, all MIT licensed, all on GitHub, so you can go and read the code yourself. There's no obfuscation there. Everything is open, right? But if you just want to get started in embedded development quickly, then you just need to know a few APIs to get started. You don't need to know all the details about TLS. Thank goodness. I don't know how many of you have actually done embed TLS configuration, but I think I still get nightmares about it. All right? Now, from an IoT perspective, it just doesn't end there at the devices. You still need cloudy stuff to help you out at scale. If you're doing your own stuff, like you're just hacking around at home, okay, maybe you don't need all this stuff. But if you're shipping 100,000 devices or 1 million devices, you definitely want to have the ability to automate your tasks. You want the ability to ensure that if there's any weird anomalies happening on the device side, that you're able to pick that up with Device Defender. You want to also have the ability to take all that rich data that you're generating at the edge and do something interesting with it by running some analytics or even curating a data lake so you can build machine learning models. And yes, You can do machine learning on microcontrollers today. It's not just a fad or a falsehood, all right? You're not like doing huge amounts of object classification, but when you're talking about things like boundary checking on vibration problems and that sort of thing, it's definitely capable today. But you still need the data in order to do that. So let's talk about how we're evolving. When we launched Amazon FreeRTOS almost 2 years ago, we got started with some silicon qualified boards from TI and from Microchip and from ST Micro and from NXP. And then we started learning a lot how this distribution of FreeRTOS was working out for our customers. And we also took a lot of those lessons and we applied it to areas outside of Amazon FreeRTOS. So let's take a look at that. Today, all you really need to know about when you're working with Amazon FreeRTOS is the MQTT agent. That's really it. Yes, you have to create a couple of structures and to get started and do an API call to get started with Wi-Fi. And if you're using Ethernet, it's even simpler. But you just need to know about the MQTT agent, right? So when we were doing 149, we made some assumptions, 149 earlier. So we just released something new 3 weeks ago. And before that, we made some assumptions. The main assumption being that a Wi-Fi or a connected device would only have one networked interface. So we made an assumption in the code that the customer only really needed to manage one network interface, and that's it. And that was not really a great assumption because what we started to learn over time was that we wanted to bring in new communication protocols like Bluetooth. And the way that it was originally coded prevented us from doing both Wi-Fi and Bluetooth, for example. If we're talking about like Espressif's ESP32, then we'd run into a little bit of problem letting the customer choose exactly what communication they would want for that qualified chip. So in the BLE case, right, how many folks have actually, well, this particular case, I almost started talking about the next case. In this case here, many times that we saw in the field is that people want to go, like, there are a bunch of devices running Amazon FreeRTOS or FreeRTOS that are not connected to the internet. And they're out in the field and they're battery powered and they're probably doing some data logging. Say, for example, it's in agriculture. And you have a worker that goes out there and turns on their mobile phone app that communicates with these devices, and then over cellular, they want to pump that data up into the cloud, all right? So we need to have the additional, that capability to have multiple communication paths in a particular microcontroller, right? This is just one case. And here, I wish I would have animated this slide, but what actually happens is, for those that may not be too familiar with mobile development in the AWS cloud, the mobile device actually talks to a service called Amazon Cognito, which is like a federation service where you get a token back so you can connect securely to AWS IoT Core, right? So this is just another service that is up in the AWS cloud. But another case, right, is provisioning. How many folks have actually bought a consumer device where the instructions say connect to your device using your mobile phone first? Anyone? And then you register, and so you have to log in with some credentials, and then all of a sudden, magically, your device is connected, right? So what's happening behind the scenes is that the server side is actually creating credentials for your device and implanting credentials in that device so then it can run solo on its own, right? So this is another case that we need to enable on the device side. It's talking BLE, it's also talking Wi-Fi. So the common starting point for these devices always, well, when you're first started programming your application, you're like, okay, I just need to create a socket, right? So you start using TCP/IP, but that's really not the level you want to operate at is working at the secure sockets level. I don't know if anyone's done any SSL or secure sockets work in the room, but it's not entirely pleasurable to write that code, right? So, and if you've done significant amounts of that kind of code, you know that across applications it can be a bit redundant. So we were able to abstract that stuff out. When I create, with Amazon FreeRTOS, an MQTT connection, I don't even see the secure socket code. All right, don't even see it. And then, even more so, what happens down at this layer down here, specifically the Wi-Fi layer I want to talk about, is there is a Wi-Fi porting layer within Amazon FreeRTOS that you are not accountable for porting. Who ports the Wi-Fi code in Amazon FreeRTOS to be able to use the board support package that comes from the silicon provider? It's the silicon provider. If you think back slides before, we had all those logos up there for the qualified boards for Amazon FreeRTOS, right? What we do is we work with those silicon partners to implement this port. And what's important about that is that we know out of the gate that that code has been written according to that silicon provider's best practices. Right? So you don't have to go and do all that churn to try to implement the code yourself. Of course, the code is there and committed. It's not precompiled binaries or any of that kind of junk. It's all open. But you don't have to do all the wiring yourself, which reduces the amount of time and stuff you need to learn in order to just get going. And then as time permits, you can go and dig in and tinker and have all kinds of fun. And then the same thing for Bluetooth. I have to speed up a little bit. So what happened then is that we were able to decouple all these different layers within Amazon FreeRTOS. All right? So the MQTT layer is decoupled from the network interface, which is decoupled from the IP and BLE. So you can see how these are all callable. And if you actually look at the code, you'll see that these are all abstracted by macros between these components. And then again, in 149 up on the top, we made a lot of assumptions. But down the bottom, actually, an interesting point I wanted to call out is this is now a wrapper. This bottom part, which is in the release 2019-06, it's a wrapper that now calls code that's being managed in a separate project, which is the embedded SDK for C. All right? So it's reused code. And then now what we have is we can then have this wrapper for a flexible user experience. Is this the? Nope, this is, sorry about that. This is the SDK part. So if you want to go and get into the guts of how you want to run MQTT on your devices, then you can use the SDK part. But if you want to have a more semi-flexible standard experience, then you can use the API directly from Amazon FreeRTOS. Now what's cool about that is it's giving you a choice, right? You're not forced to use a specific API. If you want to go low level, feel free to go low level. So the next thing I want to talk about is then about the open hardware part of it. So we just talked about FreeRTOS and all the security stuff and the connectivity stuff. That's fine and good. And actually, many of our silicon providers build the development environments on top of Eclipse, and you can use Eclipse straight up if you want to. I use Emacs, actually, to write this stuff. So you can use whatever you want, and you can use an open tool set. But what's really interesting is the stuff that we're doing with emulation, especially around RISC-V. How many folks in the room have heard of RISC-V? Awesome. Really, really awesome. So we've done significant work with RISC-V for some time now. I'm personally working with a GreenWaves board on the GAP8 processor. And I really feel excited about this platform. Now, not just the openness of it, but the ability to define use case specific hardware is just amazing. Just really amazing. Now, what I also learned at FOSDEM earlier this year is there's another initiative going on called open manufacturing, which is really great because then we can now open the door up to more people creating these silicons. Okay, so the last point I want to talk about is FreeRTOS is not the only open source project at Amazon, all right? We are this little box right there. You see the little yellow box? These are all the other projects that we're contributing to, all right? It's just amazing. Some of these actually I use internally, and some of these I've never even seen before, right? It's really amazing, the work that's been going on. But with Amazon FreeRTOS specifically, of course, FreeRTOS for the last 15 years, you could contribute using that project up in SourceForge, right? So there's the FreeRTOS project is still on its own. If you want to contribute to the kernel or you want to do a kernel port, you can still do it the same way that you've been doing it for the last 15 years, except for the license changed a little bit. The license changed from GPL to MIT, all right? That's it. Now, if you want to contribute to Amazon FreeRTOS, we just recently made it simpler for you to do so. A few weeks ago, we released the ability now that we can take pull requests directly from the GitHub project. So if you go to github.com/AWS/Amazon-FreeRTOS, you can go see our project there, and you can see all the pull requests that have been going on and all the issues that have been going on. So there's two ways that you can actually contribute to Amazon FreeRTOS. The first is, please talk to us. Communicate. If you are working on a qualified board and you're having some challenges, that is not the experience that we expect you to have with Amazon FreeRTOS. If you have an idea that you think can make it better for everyone, for the whole community, please just talk to us. It's open. The other thing, which is really cool, is now being able to do pull requests. This is a relatively new thing. People were doing pull requests, and there were some interesting reasons why we couldn't directly take it. A lot of it had to do with the internal mechanics, like technical mechanics on how we were releasing the code. But that has all totally changed. We streamlined the process, so now we can take pull requests directly from the community. And we have been doing that. And in fact, I have partners like Texas Instruments that are now doing this process as well, directly. So instead of Texas Instruments doing their porting work and their coding work and sending code on the back end to AWS, which was really weird, right, for an open source project, now they're working directly against the GitHub repository. It's really amazing. I was talking to the architect there. He's like, OK, Rich, I have all these things that I need to talk about with the service team. I'm like, Chris, just post some GitHub issues. And then not only can he ask the question to the FreeRTOS team and the Amazon FreeRTOS team, but you can communicate to the whole community and bounce off each other, even between silicon vendors. What's the best way to approach this problem? It's really, really great fun. So again, this is the cycle, and you're seeing these words around here today. This is exactly where we're at with FreeRTOS and Amazon FreeRTOS. Exactly. Get coding on it. So how many people, even if you hadn't, I asked hands for FreeRTOS or Amazon FreeRTOS, but how many people are embedded developers or they love doing embedded development on the weekend? I see a few hands. A lot of people are looking at me like I'm crazy, right? Come on, they're just little microcontrollers, nothing to be afraid of. Get coding, though. Get hacking. It's fun. And then you can complete this entire cycle. All right, so to wrap up, here's some URLs. I'll give you 10 seconds if you want to take a picture. If you don't want to take a picture, that's OK. I'm being told to hang up the phone. And thank you very much. I appreciate you stopping by today. Enjoy the rest of the conference.